Welcome to Sotantra education. In this lecture, we are going to discuss how to reverse a single linked list. So consider the linked list is given like this. So here A is one node, A is referring to B, then B is referring to C, C is referring to D, D is referring to E, and E is referring to F, and the next of F is null here. So here you can observe. So F is the last node and head refers to A. So this is the given linked list. So if we reverse the linked list, then what is going to happen? So just let us copy this one. So if we reverse this linked list, so B is going to refer to A, C is going to refer to B, D is going to refer to C, similarly E refers to D, F refers to E, and here this null is removed. So head is going to refer to this one, or F becomes the first node and the next of A becomes null. So this one is the given. So the first structure is given and the second one is after reverse. So we need to change the direction of the reference in this scenario. So how we can do this? So there are basically two approaches for this. One is we can say the iterative approach and another one is the recursive approach. So basically two approaches are there. One is iterative one. So the first one is and the second one is recursive. So in iterative approach we can use a loop and find the reverse of the linked list, and in recursive approach we need to use the concept of recursion and we are going to find the reverse of a linked list. So first we are going to discuss about the iterative approach. So first we will discuss iterative one, then we will move to the recursive. So consider one part of this one. So consider this part or zoom on this part of this linked list. So for this let me copy this part. Okay, so here you can observe node B is referring to C, C is referring to D, and just remove this because we are concentrating only on 3 nodes. So we can consider this one, this middle node as the current. So let us assume this is the current node. Now the current dot next is D. So here the next of current refers to D. We need to update this one so that the current dot next, this current dot next should refer to B. That means this arrow should refer to this one. So we need to update the current dot next. So we need to update the current dot next so that it is going to refer to its previous node, that means B. So in a single linked list the arrow is in forward direction. We know this. We cannot move backward or we cannot move in the reverse direction. So for that from C we cannot reach B. So for that we need a reference variable that is going to keep track of the previous of the current node. So assume we are taking one reference variable similar to the current and this one is back. So back is the previous node of current. So if we want to update the next of current, so the current dot next is going to refer to back. So this is the only statement we want to do. So for this we can write current dot next equal to back. So we need one reference variable for this and back is going to store the reference of B. So for this statement if we write like this, then this link is going to be deleted from here and it is going to now refer to this one. So if this link is deleted, now you can observe D is hanging in the air, we cannot reach D, or we lost the contacts for D. So the solution is like this, similar to back variable. Back is a reference variable that is going to refer to the previous of current. We can take another reference variable, that is you can consider front. So front is going to refer to the next node of current. So here basically we are taking three reference variables, one is back, another one is current, another one is front. So current refers to the present node, and back refers to the previous node, and front refers to the next node. So if we store the next in a reference variable front, in that scenario we are not going to lose the contacts of D, or the address of D is not going to lost. Okay, so now for this statement you can observe current dot next equal to back. So for this statement the link is reversed, this one, but here you can observe another link is here like this from B to C. So we have to remove this link also. So here to remove this link we can start the current from here. So here you can observe we are considering from these three nodes we are taking current at the second node. So if we start current here, then this link is going to be removed. So here you can see we are starting from current here from C. So for that the next of C is updated. So to update the next of B, we need to start from here. As because we are starting from the second position, this link is present. So if we start from the initial position, this link is going to be removed or updated. So I think the concept is clear. We need three reference variables, three extra reference variables. One is back, another one is current, another one is front. So this front keeps track of the next node of the current, and this back keeps track of the previous node of the current. So to reverse this link, just write current dot next equal to back. So this statement only, current dot next equal to back. So current dot next is going to refer to this one. Now update the value of current, that means current is going to point here or going to refer here. Similarly, if current is going to refer here, back is going to refer here, front is going to refer to its next node. So I hope this is clear. So, and another concept is we need to start from the beginning. So let us write the complete details. Now we are going to formally write the concepts that we have just discussed. So for this, take three reference variables. One is current, and initially current is referring to the head, and take two other reference variables. One is front, another one is back. So you can consider initially both are null. Okay, so now we can use a loop, and here while loop is preferable. So while the value of current is not equal to null, we are going to update the next of current. So we can write front equal to current dot next, and we can write, so we are writing front equal to current dot next. So this means we are storing the next of current in a reference variable front. That means we are keeping track of the next node of the current. So we can write here, we are writing this statement to store next in a variable, next in a variable. So now we can write, or we can update the value of current dot next. So current dot next equal to back, we can write. That means it is going to refer to its previous node. So we are writing current dot next equal to back. So initially the value of back is null, so the first node of the linked list is going to refer null. So gradually this back is going to be updated. So this statement we are writing to update the next of the current. So this statement we are writing to update the next of current to refer to its previous. So here we are keeping track of the next node and we are updating the next node. Now we will move further, that means update the value of current, update the value of previous. So for this we will write like this: back equal to current. That means the new value of back will be current, or we can say the current becomes backs and the front becomes the new current. So we will move further, or we will move forward. So current equal to front we can write. So these statements we are writing to forward, the back and current. Okay, now after this the loop is going to terminate. So initially here you can observe, initially we are taking three reference variable: current, front, back, and current is referring to head, front, back are null. So while the value of current not equal to null, the loop is going to continue and we are updating the value of current dot next. So we are updating only the value of current dot next, and we are keeping track of the next node of the current in a reference variable front. So front simply stores the value of next, the initial value of current dot next. Okay. So here we can observe, when the loop terminates, the value of current becomes null. So when the value of current is not null, the loop is going to continue. So when current becomes null, the loop is going to terminate. So if we consider this one, so suppose in this example f is the last node. So when current is going to refer, when current, so let it be in a different color. When current is going to refer to null, or when current becomes null, at that time the loop is going to terminate. So when current becomes null, the value of previous is going to refer to f. So previous just refers, or the back we can consider, here. Back is going to refer to the previous node of current, or in this particular example if we consider, when current refers to null, the back is going to refer to f, or the previous is going to refer to the f. So in this situation the loop is going to terminate. So when the loop terminates, at that time the back refers to the f. So we can say at that time when the loop terminates, the back refers to the new head. So here you can observe, so the value of back is f, or back is referring to f. So this f will be referred by head. So simply we can write, after this loop we can write the value of new head is equal to back. So this is all about the implementation of the method. So we have to write a method and implement all these steps, but for simplicity, for understanding, you can consider this one. So this is sufficient. Now we can write here the method header and some things we will write. But this is the main concept behind the iterative approach for reversing a linked list. So I hope this is clear. So next we will move to the time complexity and space complexity of this approach. That means if we follow the iterative approach to find the reverse of a single linked list, what will be the time complexity and what will be the space complexity. So we have discussed that these are the steps we need to follow in the iterative approach to find the reverse of a given single linked list. So here you can observe, these steps, current equal to head, front equal to null, back equal to null. So these are executed only once and it is going to take a constant amount of time. So we can say that these steps is going to execute or going to take a constant amount of time. So for that we can write order of 1, or we can say c amount of time. For simplicity we are writing order of 1. So now here you can observe we have a loop, and inside the loop we are updating the values of front and current dot next, and we are proceeding further, or we can say we are also updating the back and current. So these steps or these assignment operations are going to take order of 1 time or constant amount of time. So these steps are also going to take a constant amount of time, and these statements are going to execute until the value of current becomes null. So as these statements are written inside a loop, so these statements are executed until the loop terminates. So how many times the loop is going to execute? So the loop is going to execute from head to tail, or we can say the loop is going to execute n times here. So the loop is going to execute n times, and in each iteration we have constant amount of time. Now the next one, that is head equal to back, so it is also going to take a constant amount of time. So here if we consider what is the total amount, so total amount we can like say constant amount c, or we can write like this c plus constant amount n times. So for that we can write cn plus another constant c. So it is equal to, we can say order of cn, or we can say order of n. So the iterative approach to find the reverse of a single linked list is going to take order of n times. So order of n times, because n times the loop is going to execute, where n is the number of elements in the list. Now what is the space complexity? Space means how much memory, extra memory is required in terms of n. So here you can observe we are taking only 3 reference variables, one is current, front and back. Except these 3 reference variables current, front and back, no other reference variables required, or these are independent of n. So we can say this is a constant amount of memory space. So except this, now here we require some memory. So here the memory space required, or the space complexity, you can consider space complexity is order of 1, that means constant, and time complexity will be order of n. So this is the time complexity. So I hope this one is clear, the space complexity and time complexity. So now we will write a complete program for its implementation. So now we are going to write the code for the implementation of the iterative approach to find the reverse of a linked list. So for this we can write a class and assume the name of the class is node, and it has one attribute data of type char and another attribute next of type node, that is going to refer to another node. So you can take a constructor to initialize the objects. So we can write node char data, and we can write this dot data equal to data, and also write this dot next equal to null. So this step is optional, this dot next equal to null. If you want you can write, otherwise you can skip, because by default the reference variables are initialized with null. Okay, so this is end of constructor, end of class test. So now we will write the class linked list, and where we want to define the methods. So we can write class linked list, and here we are taking one reference variable head of type node, and here we are going to define the method like public void add first So we are going to add the nodes only at the first. So we can write char data here, because add first method is going to take one parameter of type char. Then we can create a new node. So node newest equal to new node and pass the data, and newest dot next will be head, and head is going to refer to the newest, and this is end of the method add first. So now we are going to write the definition of reverse. So for that we can write public void reverse, and here we can take reference variables like current, and initially the value of current is head, and other reference variables we can take like back and front. So initially both back and front are null. Okay, now we can use a loop. So while current not equal to null, we can write front equal to current dot next. So these steps we have already discussed. Then current dot next equal to back, then we can write back equal to current, and current equal to front. Okay, so now this is end of the loop. Now we can update the value of head. So head equal to back, then end of the method reverse. Now we can call, or we can define another method to display the elements. So assume the name of the method is display and the return type is void. So we can write void display. So we can take a reference variable current that refers to head. Now we can write if head equal to null. So system.out.println or print system.out.println, we can write list is empty. So in short I am writing s.vo.p for system.out.println here. So now in the else part, that means when the list is not empty, so we can use a loop to print all the elements of the list. So we can write like while current not equal to null, then system.out.println current dot data, then we can add some space, then we can write current equal to current dot next, end of method, then end of class. Now we can write another class to define the main method. So we can write class test, and inside class test we can write public static void main. So in short I am writing PSV. Then we can take a string array as argument, then we can write linked list main list. So main list is an object of type linked list, so equal to new linked list. Now we can add the elements to main list, or we can add the data to main list. So or we can say we can add the nodes to main list. So we can write like this main list dot add first, because we have only defined the method add first for inserting new nodes to the list. So similarly you can write my list dot add fast b. So we are writing inside a single quote because all the data are characters. Similarly you can write c, we can write d, we can write e, like this. We can insert the elements into the linked list. Then we can call the display method. So my list dot display, so it is going to display the elements in their original order. Then we can call the reverse method. So my list dot reverse, then it is going to reverse the elements. Then again we can call the display method. So my list dot display, so this display method, this one is going to display the elements in their reverse order because this display method is after the reverse operation. Now this is end of main method, end of class test. So we can write all the programs in a machine and check how this works. Now we are going to discuss how to find the reverse of a linked list using recursive approach or using recursion. So we know that in recursion generally we divide the original problem into two parts. One is the solution is known, and in another part the solution is not known. So if we want to solve a problem, or we can say we have a problem, and if we want to follow recursion to solve this, then we need to divide the original problem into two parts. One is the solution is known, or for one part the solution is known, for another part the solution is not known. And again we divide this part, that means for which the solution is not known, into two parts. One is solution is known, another solution is not known. Then again the not known part into two parts, one is known, another one is not known. So continuously we divide the original problem into different sub problems for which the solution is not known, and we will divide until we solve the sub problem in a primitive way or using a primitive approach or primitive operation. If we solve the sub problem, then at that time we are going to stop. So consider this problem here. So let us copy this one. So here the given linked list is like this: A is referring to B, B is referring to C, C is referring to D, D is referring to E, and E is referring to F, and the next of F is null, or we can say F is the last node and A is the first node because head refers to A. So now we are going to find the reverse of this using recursion. That means we are going to partition this one into two parts. One is the solution is known, another one is the solution is not known. That means we are going to partition this into two parts like this one and this one. So one part is node A, another part is node like B, C, D, E, F. So if we partition this in this way, then for this we know the solution, that means this will be the last node, and here we don't know the solution. That means here by any approach, we can say by any method, we are going to find the reverse, or we can say we have the reverse of this one by some mechanism and we don't know the exact mechanism, but we know that this one will be the last node. So if this one will be the last node, then here you can observe, so instead of head, so let the reference variable be current. So for simplicity, assume this is current, because we are not updating the head value, so it can lead to a problem. So we are taking another reference variable current, and current is going to refer A. So now we know that A will be the last node. So in the present scenario, here you can observe the next of current is B. So consider another reference variable, and that is front. So front is equal to current dot next. So now here you can observe, after the reverse operation, this will be the last node, and the next of B is going to refer to A, but presently the arrow is like this, but after reverse operation this will be the last node, so the next of B is going to refer to A, like in this way. So for that, what is the next of A? So we are saying that the next of A is front, because current is referring to A and the next of current is B, so we are considering that front is the current dot next. So we are taking another reference variable front, that is going to refer to this one. So after the reverse operation, A will be the last node and B is going to refer A, that means front is going to refer to current. So for that, we need to write front dot next equal to current. That means the node A will be the last node and B is going to refer to A. So for that, we can write these things, these two statements. That means this node is going to refer to this one. So front equal to current dot next, because we are taking a reference variable front, that is going to refer the next of current, and that front dot next is going to refer to the current. So instead of these two statements, we can write a single statement like this: current dot next equal to current. So we are simply here we are writing front dot next equal to current. So in place of front, we can write current dot next. So here we are writing current dot next. So in place of front, we are just writing current dot next equal to current. So either you can write these two statements, or you can write a single statement. So both have the same meaning. So now we have updated that the next of B is going to refer A after the reverse operation. Now the next of this one A will be null. So now current is referring to this one A. So A dot next will be null. That means current dot next will be null. So for that, after these two statements, or after this single one, we can write another statement like this: current dot next is equal to null. So now again divide this sub problem into two parts. Let us copy this one. So let us copy this one. So now this is our problem, and using recursion we want to solve this one. That means we want to divide it into two parts. So one part is like this and another part is this one. So here you can say this one is current. So we know that if we reverse this linked list, then B will be the last node, and these are assumed reversed by some mechanism. So these are already reversed and B will be the last node. So how B will be the last node? That means C is going to refer to B. So now at present B is going to refer C, or you can say the next of current is C, and we want to update that C dot next will be B. So for that we can write the same thing: current dot next is equal to current. That means C is going to refer to B if we write this line. Now the next of B will be null. So for that we can write current dot next is equal to null. So these two statements like we have discussed earlier, this one. So now this is the problem and we want to find the solution of this using recursion. That means divide this one into two parts. One is the solution is known, for that means C, and another one solution is not known, that means D, F, like this. So we'll proceed like this until we found that the sub problem can be solved using a primitive operation. That means when there is only one node. So like we will continue in this way, and when the last step before the final one, so like it has E and E is referring to F. So we want to partition this into two parts, one is E, another one is F. So like this, so E, another one is this one. So if we reverse, next of F is going to be updated. So for that we can write like this. So assume current is referring to this one, so it is current. So we can write like this, current dot next equal to current. Then the next of E will be null, so we can write current dot next is equal to null. Now we want to partition this one into two parts, one is the solution is known, another one is the solution is not known. So here you can observe it is the single node, so F, the single node is F, so we have only one node, and the next of this one is null, and this is the current. So as this is the single node, so without partitioning further, so we can say the reverse of F is only F, because we have only one node. But here the reverse of EF is FE, like this, but here the reverse of F is only F, no need to apply any operation. So directly we can say, so we can say this is the base case, this is the base case. So if we want to write a method using recursion for reversing the elements of a linked list, we can write like this. So the base case is like this. So in the base case, that means if there is only one node, or we can say the list is empty, so we can write like this, if the value of current is null, then return current. So if current equal to null, return current, that means if the list is empty, return null. Otherwise you can write if current dot next equal to null, that means only one node is there, then at that time also we can return current. So that is the only node, so the reverse is same as that one. So this is the base case, if current equal to null, return current, if current dot next equal to null, return current. So we can combine these two if statements using OR operation, and we can write like this. So we can write like this, if current equal to null or current dot next equal to null, then return current. So either you can write these two statement, or you can write a single statement. So both are same. So we have combined the two if statement using an OR operation here. So this is the base case. Then what is the recursive case? So recursive case means how to solve the one for which we don't know the solution, or how we partition. So recursive case. So in recursive case we can write like this. We can call the method once again, assume the name of the method is reverse, and we pass the next of current to that method. So we can write current dot next, and we proceed this, or we call this recursive method until the end of the list is reached. Now on the way back, so when we return back from the end of the list, so at that time just update current dot next equal to current, like we have discussed just now, and current dot next equal to null. So these two statements we need to write in the recursive case. Now another one is, here you can observe. So okay, so here this is our first figure, here you can see. So this is the original problem. So here, okay, so here this is the original problem. So here we are dividing the original problem into two parts. One is the solution is known, another one is the solution is not known. So after reverse operation, this A will be the last node. So who will be the first node? The first node will be the F. That means the method is going to return one node, and that will be the new head, and here new head will be the F node. So the recursive step is going to, the recursive method is going to return the new head, and we are going to update the head to the new head that is returned by the recursive method. So we can write update head. So here in this update head case we can write the head of the list is updated to the new head returned by recursive method. So now we are going to write the complete method to reverse a linked list. So we can write like this. So the method public, it is going to return an object of type node, or we can say it is going to return the head node. So public node, and assume the name of the method is reverse, and it is taking one parameter, and assume the parameter name is current, or we can say initially the current value is head. So we can write the base case like this: if current dot next equal to null, or we can say if current equal to null, return current, like we have discussed. Here we have just written the base case: if current equal to null, or current dot next equal to null, return current. So we are writing the same thing: if current dot next equal to null, or current equal to null, return current. Then we can write like this, or we are going to call the reverse operation, or the reverse method once again. Recursively we are calling the reverse method, and here we are passing the argument current dot next, and this reverse method is going to return one object of type node, and that is the new node. So here we can write node new head, that is the new head. So node new head equal to reverse current dot next, and while returning back we can update like this, current dot next equal to current, and current dot next equal to null, and we can write return new head. So this is end of the method. So this is the recursive method to find the reverse of a linked list, or you can say to reverse the elements of a single linked list. So these are the steps we need to follow. So now we are going to find what will be the time complexity and what will be the space complexity. So here you can observe this initial value of current is the head, and in each recursive call we are passing current dot next and until we reach the last node. So if current dot next equal to null, return current. So this is the base case. So when we reach the base case in recursion, the recursive method is going to stop. We are starting from the head and we are moving up to the last node, or we can say we are moving up to the tail node. So in each step we can observe there are some constant update operations are there that takes constant amount of time, and we are moving from head to tail, and as there are n number of elements in the list, so we can say the time complexity will be order of Cn, or we can say order of n. So this will be the time complexity. Now what will be the space complexity? So here you can observe we are using recursion, and the recursion method uses a stack for its implementation, and we need a stack of size order of n for this. So here the space complexity also order of n for the use of stack. Like previously we have discussed, we can write like this. We can take a class node and assume the class node have one data variable that is of type character, and it has a reference to its next node and the type is node. Now we can use a constructor. So node char data, and here this dot data equal to data. Then we can also initialize this dot next equal to null. This is optional. If you want to write this dot next equal to null, you can write. Otherwise if you want to skip, you can skip, because by default the reference variables are initialized with null. Okay, so end of constructor, end of class. So now we can write another class, that is linked list. So for that we can write class, assume the name of the class is linked list. So here we can take one reference variable head. Now we want to write a simple method, that is add fast. So we have already discussed about the steps in the method add fast. So simply we can write like this, public, and assume the method is going to return an object of type node. So we can write public node, or we can say this method is going to return the head after insertion. So for that we are writing node. So we are writing node because the head is of type node, and after execution of each add fast method, this method is going to return the head or updated head. So the method like this, the name of the method is add fast. Then it is going to take one data, or it has one parameter data of type character. Then we can write like this, node newest equal to new node data. That means one new node is created, and we are passing the value of data as argument. Now we can write newest dot next equal to head, because we are inserting at first position. Then we can write head equal to newest, then we can write return head, then end of this method. So this method add first always returns the head after adding one element to the linked list. Now we can write another method, that is reverse. So we are going to follow the steps that we have already discussed. So public, assume the method also going to return one or going to return the head after executing all the steps. So public node, we can write the name of the method is reverse, and it is taking the parameter of type node, and here we are telling that it is current. So for that I am writing curr, or it is, we can say it is going to take the head. Okay, so now if we can write if this current equal to null, or we can write current dot next equal to null, we can write return current. Node, assume it is the new head. So node new head equal to reverse current dot next. So we are calling the method recursively here, and we are passing current dot next as the argument, and it is going to return the new head. So now we can write current dot next equal to current, and current dot next equal to null, then we can write return new head, like we have discussed earlier. So this is end of method reverse. Now we can write the display method. So void display, and we are passing the head as argument. So here we are taking another variable current, that is equal to head. Now we can write if head equal to null, that means the list is empty. So we can write system.out.println empty list, or we can write the list is empty like this. Else, that means if head not equal to null, so you can use a loop. So while current not equal to null, system.out.println current dot data, and we can write some space. Then we can update the value of current. So current equal to current dot next. So all the things we have written inside a while loop, and here this is end of else. So this is end of loop. So let it be a different color. Okay, so this is end of loop, this is end of else, and after that end of method. So here we can take a different color, blue one. Okay, so now we can write the main method, and we can execute the, or we can invoke all the methods that we have written earlier. Like the reverse method we can invoke the display method, we can invoke the reverse method, we can invoke the add first method from the main method. So we can take another class and assume name of the class is test, and in the test class we can write public static void main. So insert I am writing psvm, then string arguments, then we can write linked list, and the object name may be main list. So linked list main list equal to new linked list. So we can create a linked list object like this. Then we can call the add fast method. So we can call mylist dot add fast and pass a. So pass a, so a is a character, because this add fast method is going to take one character only, so we can write in a single quote a. Now add fast method is going to return the head, so we can write node head equal to mylist dot add fast a. Similarly we can write the same thing, node head, that means the same head is updated. So don't write node heads, only write head, because we are going to update the same head. So head equal to mylist dot add fast b. Similarly we can write add fast c, add fast d like this, add fast e like this we can write. Now we display. So before the reverse we can write mylist dot display and pass the head value. Okay, so now we can call the reverse method. So for that we can write mylist dot reverse and pass the value of head. So this reverse method is going to return the new head. So we can write head equal to mylist dot reverse head. So it is taking the argument head and returning an object, or you can say it is going to return the updated head. So next we can write mylist dot display head. So this is going to print the elements of the linked list. So here this one is called after the reverse operation, so it is going to display the elements in reverse order, and this display method is called before the reverse operation, so it is going to print the elements of the linked list in the original order. So I hope this is clear to everyone. So this is end of main method, end of class test. So now we'll implement or write the programs in a machine and check how it works.